All right, for the second day of this lesson, we're going to figure out what a reference angle is. If theta, so again, the symbol here, we talked about it yesterday, and it just means an unknown angle measurement, is in standard position. Okay, so we know the initial side is on the positive x-axis and the terminal side is somewhere. Its reference angle and the reference angle is called alpha. So that's a new one for us. And basically all it is, it's kind of, let me draw it for you. It's like this. Almost like if you were drawing fish when you were a kid. So alpha is the acute angle. So if it's an acute angle, then we know that angle must be found in quadrant 1. So basically that's what we're doing. We're going to be given an angle that is not in quadrant 1, or it could be in quadrant 1, and we're going to reference it back to quadrant 1. What this is going to do is this is going to help us when we go to start finding sine, cosine, and tangents of these different trig values. We're going to take the other quadrants and reference them back to quadrant 1 to make it easier on us so we don't have to memorize as much. So first let's talk about the different notations here. So in quadrant 1, if your theta is in quadrant 1, that's just going to equal your alpha. So in quadrant 1, there's not anything really different. Your theta and your alpha will be the same. So your angle that we're talking about is here. So that is the angle of alpha and the angle of theta. And here is basically what you're trying to memorize. But again, for the first one, we don't really have to memorize anything. So in quadrant 1, for quadrant 2, our x that we're using is here. And then our theta goes all the way to quadrant 2, but in order to make the angle reference back to quadrant 1, you're going to take 180 minus that angle, and that will make an angle that is less than 90. So for quadrant 2, and it has it for degrees and for radians because you will be given both in the examples, but you'll take 180 minus whatever the theta is, and that'll be your alpha. Or pi, because pi is equivalent to 180 degrees minus theta, and again, that'll be your alpha. For quadrant 4, so you can choose to memorize these, or you can just kind of think about it and say, how am I going to be able to get that angle to go back to quadrant 1 and be less than 90? In the beginning, that's very challenging, so this might be a good option. And I will put this in a little chart for you to make it even easier for you to remember. So for quadrant 3, we're taking theta minus 180, since we know if we're in quadrant 3, it must be greater than 180. And then lastly, for quadrant 4, you're going to take 360 degrees and subtract that from theta. So one other piece that I just wanted to add on here, because we're still getting used to circles and units and angles. So this would be 0 degrees, this axis here, and this axis here would be 90 degrees. But in terms of radians, this would be 0, and this would be pi over 2. So this quadrant 1 is between 0 and 90 for degrees, or between 0 and pi over 2. And then I want to do that just for quadrant 2 as well. So this would be 90 degrees to 180 degrees. And in radians, that would be pi over 2, and this will be pi. For quadrant 3, this will be 180 degrees. And then this piece here will be 270 degrees. And then in radians, that'll be pi, and 3 pi over 2. So just trying to get us more acclimated with angle measurements and the degrees. Here we would have, this would technically be 360 because we finished the circle. And here again is 270. And then in radians, 360 is equivalent to 2 pi, and 270 is the same 3 pi over 2. Now let's go ahead and take a look at an example. So it says, find the reference angle for each value of theta. Okay, one thing just to note, the directions probably would also say that your alpha must be between 0 and 90 degrees or 0 and pi over 2. Okay, and again, all this does is tells us that we will be in quadrant 1, but that would probably be a restriction on it, so they would have that reference angle go back to quadrant 1. So for number 3, part A, we're talking about 325 degrees. So the first step, I'm going to kind of list this out a little bit. The first step is to find what quadrant. Okay, so what quadrant does 325 lie in? Well, if we go back up here to our circles, 325 degrees we know is between 270 and 360, so it's in quadrant 4. So you know it's in quadrant 4. And then we would basically follow what the directions say for quadrant 4. So for quadrant 4, it says to take 360 minus theta. So if our theta is 325, we would take 360 minus 325, and that's going to give us, oh, I wrote a little crazy there. That's going to give us 35 degrees. So our alpha is equal to 35 degrees. So that would be our reference angle. Part B, we have 515 degrees. So 515 degrees is past our circle because our circle only goes to 360. So on this one, before you figure out the quadrant, we actually need to find the coterminal angle. And the reason we need to do this is because it's over 360 degrees. So it's going past a circle. So to find the coterminal angle, we're going to take the 515 and subtract it from 360, which is going to give us 155 degrees. Now we'll go back and see what quadrant this 155 degrees is. So 155 degrees is between 90 and 180, so that would put us in quadrant 2. So we're in quadrant 2. So then we go back up and we do what it says for quadrant 2. So quadrant 2 says to take 180 minus theta. So you're going to take 180 minus your 155. Use your coterminal angle. So that's going to give us 25 degrees. So our alpha is 25 degrees. Now let's try a couple where we're given radians. Same directions. We're just going to have radians now. And it's the same process. It's just a little bit uglier because our numbers are fractions. So first thing is we got to figure out which quadrant this lies in. But in order to figure out which quadrant, what we kind of want to do, so let me just put here. So we know this is 0, this is pi over 2, this is pi, 3 pi over 2. Basically, we got to figure out where the 4 pi over 9 lies in this range of numbers. So for instance, we know that this is basically the same as 1/2 pi here. So if you were just to compare ratios of 4 over 9 and 1/2 to try to figure out if it's smaller, so in quadrant 1, or bigger in quadrant 2, 4 over 9 we know is less than 1/2 because we need it to be 4 over 8 or 5 over 10. So because this 4 over 9 is less than 1/2, then that's telling us that it lies here in quadrant 1. Had this been reversed, had the 4/9 been bigger than the 1/2, then it would have put it in quadrant 2. So because of this ratio, we know it's going to be in quadrant 1. For quadrant 1, the directions for theta, bring that back, alpha is just equal to theta. So even in radians, we're just going to say that our alpha, so our alpha is just going to be 4 pi over 9. So that one we didn't have to do anything in. So anytime it's in quadrant 1, it basically will just end up being whatever you started with. So our next example, 10 pi over 3. Well, if we think about, again, and let's make this side 2 pi. 2 pi. 2 pi means that if we were to take 3 and divide it into 10, it goes over 3 times. So we're going beyond one full rotation of a circle. So we need to figure out the coterminal angle on this because this is over 2 pi. So we got to find the coterminal. And again, the reason is because it's over 2 pi, which again is equivalent to our 360 degrees. It's going beyond the circle. And for radians, we basically subtract 2 pi. So if I take 10 pi over 3 minus 2 pi, let's do some fraction work. So multiply top and bottom by 3. So that way everything matches. So then 10 pi over 3 minus 6 pi over 3. I know I'm showing everything so nobody can get confused. So this will give you 4 pi over 3. And now we need to figure out where does this 4 pi over 3 land. So for instance, we know that 3 goes into 4, 1 and a little bit extra. So I know that that value is greater than pi. So then the problem becomes is it greater than 3 over 2? So again, compare your ratios. And for some of you, you may find this much easier than others. So I'm kind of showing you the way if you're having trouble with this. So if I take 4 over 3 and I compare it to 3 over 2, well, you know this is 1.3 and you know this is 1.5, so it's less than. So since it's less than, it's not going to go to quadrant 4, it's going to stay in quadrant 3. So I know this is in quadrant 3. And again, you might have to rewind and listen to this again so it makes sense. Quadrant 3, if we go back to our chart, says you do theta minus pi for quadrant 3. So we're going to do theta, which is the 4 pi over 3 now because we're using our coterminal. And we're going to subtract pi. Again, you might need to make common denominators. So times by 3. So this will be 3 pi over 3. So 4 pi minus 3 is just going to be pi over 3. So our alpha is pi over 3. So there's a lot going on when you're working these problems out, but hopefully those examples will help you on homework. I just wanted to take a second to go over the different things we discussed so far from day 1 and day 2. So first, I just wanted to briefly touch on standard position again because it is so very, very important. So for standard position, your initial side must be on the positive x. Your terminal side can go wherever it wants to go, but your initial side, so let's say we're just going to have our terminal side, and I know this is horrible. Terminal side. Okay, so standard position, and then we know that the angle that's created here would just be our theta. And then coterminal angles are angles that start and stop. Oops, that's supposed to say stop. Angles that start and stop at the same place, but have different rotations. Okay, so on a picture, the two angles, if they're coterminal, they will both look like, let's say, like this. They'll both go to here, but one might go a full revolution of 360 plus that, where one might not go that far, but they're both in the same spot, but they just have a different amount of rotations that they take around. Then lastly, a reference angle is basically an angle. Oh, sorry, you guys can't write and talk. An angle in quadrant 1 that references the original angle. All right, I know it's confusing. Again, watch it a couple times, practice it on your own. I will post the homework answers like normal.